Dear students, myself Dr. Sangeeta Sharma, Associate Professor PG Department of Chemistry, Government डूंगर कॉलेज बीकानेर। आज हम MSc प्रीवियस में पेपर थर्ड यूनिट फोर्थ सरफेस केमिस्ट्री सरफेस एक्टिव एजेंट पढ़ेंगे। Substances that drastically lower the surface tension of water even at low concentrations are called surface active agents or surfactant. All surface active agents get preferentially adsorbed at the air water, oil water and solid water interfaces, constituting an oriented monolayer within the hydrophilic group point towards the water phase and the hydrocarbon chain point towards the air or towards the oil phase. Surface active agents are strongly positively adsorbed at air-water interface. Agents that increase surface tension are surface active but are not called surfactants since their effect is opposite to the common meaning. Surfactants are usually organic compounds that are amphiphilic, meaning they contain both hydrophobic tail and hydrophilic group their heads. Classification of surface active agents. Surface active agents are of the following types. First, cationic surface active agents. Those substances which dissociate in water to give positively charged ion, for example, cetyl trimethyl ammonium chloride, C16H33CH3 whole thrice N plus Cl minus, cetyl pyridinium chloride, C16H33 benzene NCl, octahedral ammonium chloride, C18H37 NH3 Cl negative. Anionic surface active agents. They are sodium salt of higher fatty acids such as sodium palmate, C15H31COONA, sodium stearate, C17H35COONA and sodium olate. The salt of sulfonic acid of higher molar mass and general formula CnH2n plus 1 SO3M alkyl sulfonate and or CnH2n plus 1 C6H5 SO3M alkyl aryl sulfonate, where M is a univalent cation like sodium, potassium or ammonium, also act as a anionic surfactant. Non-ionic surfactant or surface active agent. Those substances whose molecules cannot undergo dissociation when an alcohol having higher molar mass react with several molecules of ethylene oxide, non-ionic surfactant obtained. CnH2n plus 1 OH plus M molecule of ethylene oxide give rise to CnH2n plus 1 OCH2 CH2 M molecules OH. A surfactant can schematically be represented as a hydrocarbon radical as a polar head and hydroethylene chain as long tail. The hydroethylene chain is quite long and slightly hydrophilic due to interaction between the ether, oxygen and water molecules. Forming hydrogen bond is coiled in solution and binds water due to the enthalpy effect. The hydrophilic nature of hydroxyethylated surfactants are controlled during their synthesis by changing the number of carbon atom in a hydrophobic chain, but also the number of hydroxyethylene group. Non-ionic surfactants are soluble in hard water. Hydrophobic surface will become hydrophilic when they adsorb from aqueous solution, and their examples are octaethylene glycol, monododecyl ether, nonoxynol, or triton X100. Next is zwitterionic amphoteric surfactant. Those have both cationic and anionic centers attached to the same molecules. The cationic part is based on primary, secondary, tertiary amines or quaternary ammonium salt. The anionic part can be more variable and includes sulfonates. Betanes have a carboxylate with the ammonium. The most common biological zwitterionic surfactants have a phosphate anion with an amine or ammonium. For example, lauryl dimethyl amine oxide, myristerium oxide. Micellization. The micelles or ionic micelles are defined by McBain are the cluster or aggregates formed in the solution by colloidal electrolyte. The micelles may contain 100 or more ions clamped together with a considerable number of water molecules. Micelles may be defined to be aggregates of long chain diphilic surfactant molecules or ions formed spontaneously in their solution at a definite concentration. Depend on the nature of polar group and micellar mass, sum of molar mass of aggregated molecules. Micellization is mostly phenomena of micelles formation occurs from the large ions of molecules in solution, with exception micellization from neutral or non-ionic molecules, polyethylene oxide. Usually such molecules have lyophilic group and lyophobic group. A typical example of is a soap, and which is denoted as RCONA, having two parts. First, the long hydrocarbon part R dash, which is hydrophobic. It tries to keep away from the solvent, and tail, the COONA part, is ionizable and lyophilic. It tends to go into the water, resulting into sodium ion and COO minus ion called head. RCOO minus group will orient itself in a way as to make COO negative and projecting outward in contact with solvent, and R tend to away from the solvent. As concentration of soap solution increases, RCOO negative sodium positive comes closer. The R group part approach each other because they do not carry any charge, so they do not repel each other. These parts then form a cluster or aggregate called micelles. The micelles is supposed to be spherical. The methyl R and R in the inner and CO negative group are projecting outer side in contact with solvent. The micelle is thus a colloidal particle with charge on the surface to which oppositely charged sodium ion would be attached, forming double layer. Micellization occurs when a particular concentration is reached at a given temperature, called CMC, critical micellar concentration. Thermodynamic of micellization. Hydrophobic interaction can be regarded to be the thermodynamic driving force of micellization. The hydrocarbon part of diphilic molecules get forced out of the aqueous medium to avoid contact of the chain with water as much as possible, and due to this the micelles are formed. Their internal part, the core, consists of liquid hydrocarbon, while the external part, which faces the aqueous solution, has polar group. Micellization is a spontaneous process, that is, the change in free energy delta G is equal to delta H minus T delta S, where H is enthalpy and S is entropy, becomes less than 0. The main contribution to the value of delta G is made not by the change in enthalpy, which is insignificant in magnitude, but by the change in entropy T delta S. Entropy of the system increases, delta S is greater than 0 as removal of hydrocarbon chain of the diphilic molecules from water into the micelles disorders the structure of water. Mechanism of micellization. A growth in a concentration C is accompanied by an increase in the chemical potential of the surfactant, denoting the tendency of the component to leave the solution. The surfactant ion pass into the surface layer at the interface of the surfactant with the other phase at low concentration. The free energy of the system decreases. The surface layer gets saturated with further increase in the concentration. The system expels the hydrophobic chain from water into the liquid pseudo phase, which is a mixture, and separates it from water by the hydrophilic shell of the polar groups. This phenomena is known as self-adsorption, causes a gain in energy of 2000 joule per CH2